So biology is the study of life. Anatomy is structure. And physiology is function. So you're going to see how these two mirror each other, why anatomy is what it is. So you're going to have to learn the terminology. I do have a PowerPoint up that has the body cavities ready for you for lab. So it's really important that you understand the terminology. And I'll go through it with you. So again, structure and function. And why do we learn this? Of course, this is your textbook, by the way. I left this on this particular PowerPoint, so you know this is the one we use. It doesn't have to be the 13th edition. It could be an older one. So you're going to be able to communicate all the different parts of life, really, of the human. Of course, there's human anatomy and physiology. So I always like to start with the levels of organization, right? Because in this class, you're going to cover them all. So anybody know, like, what's the smallest particles, not even living, smaller than a cell? What's smaller than a cell, smaller than an organelle, even smaller than an atom? What would we say? Let's say atom is up here, right? Atom is here. But before atom, you have subatomic particles. So here you have, there's a positively charged particle called a proton, right? We're going to learn that in chemistry. Then you have a neutral particle called a neutron. And these have mass. These are not living. These are part of a magnetic field, which I'll tell you. So anybody know the electric, it's electric, of course, but anybody know the negatively charged subatomic particle?
Electrons.
Of course, the electron. And that's negatively charged. So you know the Earth, right? That round thing that we live on. It has its two poles. There's a pole in the north with the big guy with the red suit, and then there's a south pole. So that creates a polarity, a difference in size, and there's electromagnetic field between those two. So there's a lot of these particles that make that up. So the electron is negative. The proton and the neutron, they basically stay at home in the atom, right? And subatomic particles are the first thing, first level. Atom would be second. The neutron also stays at home, and they call that the nucleus of the atom, not the nucleus of the cell, the nucleus of the atom. But this electron, this is the guy or gal that likes to party, likes to go out and bond with other atoms and form molecules. So this electron creates a lot of energy when it moves from one place to another. And it's really all about the outermost electron, because not all atoms have the same amount of electrons. It varies. And we'll take a look at that in chemistry and look at the atomic numbers and the periodic table. So the electron is going to make a difference with these particular atoms. So atoms, again, are the smallest non-living, if you say, but really subatomic particles are even smaller. And there's even smaller quarks within these, and neutrinos that are even smaller. But let's start at subatomic. I like to start there because you need to know about the electron. You need to know about the proton. And in chemistry, you need to know about the neutron. So anybody take a guess, what are the 4 most abundant atoms or elements in the human body? Anybody know? Just name anything.
Oxygen.
Yeah, oxygen. Now that's not the oxygen we breathe, because the oxygen we breathe is O2, and that's a gas. But oxygen is an element, and it's really a big one. Anything else? Carbon. Yeah, I like carbon. And you're going to learn in chemistry that carbon, and the next letter, is going to be what makes a molecule organic. That element or atom. When I say element, it just means a lot of one atom. So kind of try to understand that. Very good. Anything else? I can't believe you guys knew this already. What else? Hydrogen?
Hydrogen.
Yeah, hydrogen. That's a big one. That's probably the most abundant. A lot of hydrogen. Anybody remember another one? One more? You got to mute your mics, man. Come on. going to slow us down.
It's a salt, but I don't know the other chemical.
You don't know the other?
Isn't it nitrogen?
It's nitrogen. Very good. Nitrogen. So CHON, which is carbon, hydrogen, oxygen, and nitrogen. Very good. And those are the most abundant in the human body. Right? And you're going to learn other atoms, and you're going to learn what ions are. And ions are charged atoms, meaning they either gained electrons or they lost electrons. So if they gain electrons, they're going to be more negative. And if they lose electrons, then they'll be more positive. Like hydrogen, for example. Hydrogen is an element, an atom. It's the smallest of all on the periodic table. Does anybody know what the atomic number is of hydrogen, which means how many protons it has and how many electrons it has and neutrons? It's the simplest number, the smallest number.
One.
Just
One.
one.
Six.
Just one. Yeah, carbon is 6. Good.
Carbon is
So-
6.
So hydrogen only has 1 proton and 1 electron. So if hydrogen loses that 1 electron, which it does very often, it becomes a charged ion, a positive ion, a cation. And this is really an important ion. And this is what creates what's called acid. You're going to learn that later on. So this is an ionic form. And then you're going to see other ions we're going to talk a lot about. And it really is kind of difficult. So I'm going to mention it a lot. I want to mention it here. So did anybody know what this is? Na?
Sodium?
Yeah,
Sodium.
sodium. Excellent. So sodium is really important. It's Na because really sodium used to be called natrium. But sodium tends to lose electrons. So it's more of a positive ion in its ionic form, Na. How about this one? Anybody know what this one is? The letter doesn't match the name.
Potassium.
That's potassium. So potassium tends to be more positive when it loses electrons. Very good. So the stable part of potassium just looks like that. And what about this one, Cl?
Chlorine.
Yeah, chlorine. And if you gain an electron, this chlorine, based on how many electrons it has, it tends to gain an electron. So that's more of an anion or negatively charged. That's why these two go together so well through an ionic bond. Sodium chloride, right? You ever have table salt? They form a nice, neat bond, a nice salt bond. It's not the strongest bond, but it's pretty good because of this electron that loves to get lost and gained in an ionic bond. So we'll learn all about that chemistry. So now, what's after atoms? Let's like put 2 atoms together. Like let's put 3, well, 2 of 1 element, but 3 atoms. Like this. You ever hear of this? H2O.
Compounds.
This is a compound molecule. Very good. That's true. That's a compound molecule because it has different elements in it. And then there's this one, which is not a compound molecule. We just call it a molecule. That's oxygen gas, O2, right? And then you have CO2. And what's oxygen? Now you know oxygen, right? That's oxygen gas. What's CO2? What's that called? This molecule.
Carbon dioxide.
It is very good. And I'll tell you right now, our body loves oxygen. We need oxygen. We can't live without oxygen. You probably know that. But our body hates carbon dioxide more than it loves oxygen. Our body wants to get rid of carbon dioxide. Not much need for carbon dioxide in our body. Can we live without it? I'm not sure. But we really want to get rid of it. We don't want excess carbon dioxide in our blood. And when we're talking about the body, we're talking about what's going on in the blood a lot of the time. Then there's another, let me just show you this one, just to give you an idea. C6H12O6. Now, 6 carbons bound covalently to 12 hydrogens, and there's 6 oxygens bound covalently as well. So this molecule, anybody know what this is? This is what we need for energy. This is what goes into our cells, and it's broken down through glycolysis, and then we use it to make energy. So these are molecules we're talking about. Anybody know what that molecule is down here, this big one? All that carbon and hydrogen? This is glucose. This is glucose. We talk a lot about glucose. So let me ask you this: of the of CHON, right? CHON. Which one element do we need to make a compound or a molecule organic?
Carbon.
Carbon. It's carbon. And we usually have hydrogen with it, almost always. Sometimes oxygen, well, a lot of times oxygen, sometimes nitrogen. Now this carbon dioxide has carbon, but it's not organic. It's an exception, which was when we talk about chemistry, I'll show you that. And water, like I always ask this, and I'm not going to ask it because I just want to tell you that H2O is not organic because it doesn't contain carbon. It's miraculous. Our body is at least 69% water. And all our fluids are like 70 to 90% water, depending on what fluids we're talking about. So these molecules all have different functions and different reasons for what they do. So does anybody know, let's say let's go to Chick-fil-A, right? We'll go to Chick-fil-A tonight, getting hungry. And we get chicken, we get some fries, maybe a little treat afterwards. So basically what we eat is basically making up our four, or definitely three of the four macromolecules, organic macromolecules. Means big molecules. So these are going to have to remember. I might as well do it now. So what are we eating? What, like if we eat the French fries or just say the bun of the chicken sandwich, what nutrient is in that? That's an organic macromolecule. What's the main word for it? And glucose is an example of it.
Starch.
It could be starch, which is called very good, which is called a carbohydrate. And this is the one macromolecule we really want to use for cellular energy. Like this, glucose is a monosaccharide you're going to learn. So starch is a polysaccharide that we need to break that down to glucose and try to digest the glucose and use it for energy. Very good. So what about the chicken meat? What is that? You guys know, girls know?
Protein.
Protein, right? Protein. So proteins are made of amino acids. Proteins we don't want to use for energy, please. We want to use proteins for body structure, our bones, our muscles, all the structures that hold organs together, all that tissue, that connective tissue we're going to talk about. Very good. So protein we don't want to use for energy. It's structure. And we use them for enzymes too, we're going to say. What about that like yellow stuff that's on the chicken sometimes? And it's kind of slimy. And you see it a lot in red meat too, but not so much in chicken. But you're going to get it fat, yeah, but we call that lipids, right? Lipids. Because lipids contain fats. Like when we go to Chick-fil-A later, you're going to have plenty of triglycerides, which is an example of a fat, and it's one of the fats we store. So triglycerides are lipids, and we store them in our adipose tissue for long-term energy. Very important. So very good. Those are the three ones that we talk about when we eat. So the last one is going to be nucleic acids. Anybody know an example of a nucleic acid? There's only three we really talk about.
DNA and RNA.
Yeah, very good. Deoxyribose nucleic acid and ribose nucleic acid, right? So just a little difference in one of the oxygens, and DNA has less. So DNA is really, this is something that makes up our genes, which makes up our chromosomes that have been handed down to us for thousands of years. And this is really unique to us. Our DNA is so microscopic, it could wrap around the world. But guess what? It never leaves the nucleus of our cells. It stays in there. Messenger RNA takes the message from DNA and brings it to an organelle in the cell to build proteins, to build who we are structurally, and maybe a little more than that as the research goes. So that's very good. So there's the nucleic acids, and we'll break those down in chemistry. Now there's another one that is actually a nucleic acid that we use for cellular energy. Anybody know what that three-letter compound is? I'd be really happy if you did. But if you didn't, I'm going to tell you. It's like our energy currency in our cells.
ATP.
Wow. ATF and P, way to go. Adenosine triphosphate. That's a nucleic acid. That is a nucleotide of a nitrogenous base, a sugar, and a phosphate. So ATP is our cellular currency. So if you put like these three things together, pay attention to this. Like we have glucose going into our cells. That's C6H12O6 carbohydrate. And then in the presence of oxygen, and then in a place called the mitochondria, which you can learn later, the mitochondria takes the byproducts of glucose with oxygen and makes a whole boatload of ATP so we can run our cellular metabolism. Way to go. Excellent. Cool. So that's enough about molecules. I spent a lot of time there, but that's really important. So we know what a cell is, but what are those little, like I mentioned, the mitochondria, which is where the electron transport chain is, and the Krebs cycle, where the oxygen is used through aerobic respiration to make a lot of ATP. So what do we call like the mitochondria, the lysosome?
Organelle.
Yeah, cute little organs called organelles. I like to throw that in there so you know, because this is where we're going. If I could spell, I'd be all right. Organelles. So yeah, the nucleus technically is an organelle, where the DNA is, the nucleolus, the little ping pong ball within the nucleus, the centrioles, the lysosome, the Golgi apparatus, the smooth endoplasmic reticulum, the rough endoplasmic reticulum, my favorite, the mitochondria, and the ribosome. That's probably my second favorite, because the ribosome, this is a miracle really, is really where RNA brings that message from DNA to build protein. So the ribosome is the site of protein synthesis. So building proteins on there, we're using RNA that got its message from DNA. So we have a whole lab on that, or half a lab on the cell. We'll talk about it in a lecture about too. So if we put organelles together inside a membrane, a plasma membrane, which we're going to spend a lot of time on that too, then you have the cell, right? Then we have the cell, which we're going to learn. There's trillions of cells, but there's many different types of cells. So if you put one type of cell together, what do you form? If you put groups of cells together, what's the next level of organization?
Tissue.
Tissue, I hardly know you, right? Tissue. So that's a group of similar functioning cells. So there's 4 basic tissue types that you have to learn. And anybody name a basic tissue type? Think about it for a second. What are 4 basic tissue types in the human body?
Connective.
Wow, that's a tough one. Yeah, connective tissue. CT, connective tissue.
Yo-yo.
Then there's epithelial. I don't know why I'm putting them in this order. And then there's one you're going to learn a lot about in this semester, and that's nervous tissue. You're going to do skeletal muscle, but you still need to know muscle tissue when we do the tissue lecture and lab. So epithelial tissue basically lines and covers, and it's your glands. Very avascular. It relies on transport for nutrients. Muscle, again, not the brightest tissue in the world. You know, it needs nervous impulse, and cardiac muscle has their own nervous impulse within them. So you learn that mostly in AP too. But you have to know what it looks like, and we'll see histology of cardiac muscle. And then there's smooth muscle, which is really you have to see what that looks like too in the lab, and you have to know that smooth muscle is involuntary, cardiac muscle is involuntary, but skeletal muscle is voluntary. And we'll look at the histology of those 3 muscle types. Connective tissue is kind of difficult because there's so many different looks to it, and like nervous tissue is easy to look at, but it's just a huge part of AMP1 here at CCM, where we're going to spend a lot of time on the nervous system, especially at the end of the semester, and we'll do our dissections. And but by then you'll know all these other levels of organization. You'll feel more comfortable. So let me ask you this: like, where do you think bone fits in to these 4 basic tissue types? Tough one, right? Bone is actually connective tissue, so we're doing bone this semester. Adipose is a connective tissue, and you'll see why by definition. what tissue they derive from the embryological tissue when you're first conceived. Adipose is a connective tissue. So connective tissue is not just parts that connect, like a ligament, right? You've heard of a ligament, the anterior cruciate ligament, the lateral collateral ligament. Ligaments connect bone to bone, and they're dense, regular connective tissue. And then you have like a tendon. A tendon is connective tissue. It's also dense, regular connective tissue, and a tendon connects muscle to bone. Then you might hear a term like fascia, which is dense connective tissue, regular connective, dense regular, and that kind of is in between muscles, so it kind of connects muscle to muscle. So we're going to spend a lot of time in lab on connective tissue and lecture too. But you know, like I said, 13 weeks, I'm going to try to make it so it's kind of an easier flow between the two, since you have the same instructor. So if you push tissues together, like say all 4 tissues together, what do we get? Like the heart or the stomach or the liver or the brain. That would be an organ, right? Organ. And then 8, if you put different organs together, would be an organ system. And you have to kind of know the organ systems for this lab to lecture. Like all of them, a little bit about all of them. Like basically what they do. You know, I have a narrated PowerPoint on that, which I think will be helpful to help you through that. So an organ system, what are we studying? We're doing, I think the first organ system we do is the integument. Anybody know what the integument is?
Skin.
Yeah, skin, hair, and nails. So we'll do that. So the skin basically has all the tissue types, all 4. It's got epithelial, it's got muscle, it's got connective and nervous. So it's not just epithelial tissue. In fact, only the outer layer of the skin is epithelial tissue. And the glands within the dermis, you'll learn all about that, skin, and all about epithelial tissue. So then we do skeletal system. Remember, bone is connective tissue. You really got to talk about calcium homeostasis, blood calcium, and fracture repair, and bone growth, and all the hormones that go along. Remember, hormones are part of the endocrine system. So even though we're not doing the endocrine system in AP1, I'm going to mention it a lot, especially when we talk about the nervous system. And even now, today, when we talk about feedback mechanisms and homeostasis, you really have to know how the endocrine system works together with other systems, especially the nervous system. What else do? We do muscle. Muscle is a system, and mostly we're doing skeletal muscle this semester. And then we jump right into the nervous system, which is huge. Huge. I don't think I missed any. So nervous system is like 3 or 4 chapters combined. So it's a lot. And don't forget the exam, departmental final is cumulative from all of this stuff. So if you get a good feel of where we're going with this, why I'm spending so much time on this memorization stuff, like memorizing this levels of organization from bottom to top. Because number 9 is us, right? Number 9 is the organism. Okay. So you have to know all the steps to get to that organism. And it takes 2 semesters to really know all these things. So we got to do chemistry, because chemistry is part of all of these all these levels. And all the physiology, the function is really important. Knowing the chemistry besides the biology. So gross anatomy is just looking with your naked eye, or macroscopic. So what you can see. So it's important that you're able to do that. You'll look in lab, you'll look at the torso man, and you'll be able to know that the liver, most of the liver anyway, is in the right upper quadrant of the abdominal cavity, and some of it goes over to the left. The stomach is only in the left, so you can see what it looks like visually. You know, if you took the stomach away, you can see the pancreas, so visual stuff, you know. And of course, you have to learn medical not medical, but anatomical terminology. Like what is anterior? What is posterior? What is ventral, dorsal? Basically, ventral is anterior, dorsal is posterior. It depends on if the mammal is lying down or standing up. Because we're mammals, right? We're mammals, like the dolphin. You know, we have teeth, we have some fur, we have nipples, and we carry our young or our embryos in the uterus. So we're very similar genetically to other mammals like a mouse, rat. So that's why we study rats and mice. So that's kind of a comparative anatomy. But you're gonna have to know the terminology. You're gonna have to know like the shoulder is called the acromion, the back of the knee is popliteal. So it's like a new language in a lot of ways if you haven't taken any high school anatomy and physiology. And the first practical is going to be a lot of questions on like, what does this body system do? What's another name for the front of the knee, like patella, or what you'll know what the femur. You'll know what the femur is. It's a big bone, but you'll know that the upper thigh can be called femoral and crural and sural. All these weird words for the lower leg, brachial for the upper arm. So it's worth it to do. That's something you really have to read ahead a little bit and practice. And again, we don't have mastering. We're not going to use mastering. Mastering was a pretty good breakdown of all those things, that little exercises. But you could use your textbook. You could use your lab manual, of course, drags you through all of that stuff very well. The big expensive book is really good for that. So it's just as good as having it online. Then microscopic, we're going to study histologies, and of course, we know what the cell looks like, but most of the time we'll spend looking at histology slides, like different tissue. We'll spend a lot of time learning in lecture and lab, learning what epithelial tissue looks like, what are the highlights of epithelial tissue, what the different epithelial tissues look like under a microscope. So bring your cell phones, of course, not to go on Facebook and buy stuff, but to actually take pictures of the microscopes. If we get good microscopic slides, well, hopefully that'll happen in that lab 3 or 4. So you look at that, you look at bone tissue, you'll see that's connective tissue. Of course, you look at connective tissue, then spend a little time on muscle and nerve in that lab, but then when we get to the muscle lab, we're really learning the big muscles, mostly the gross anatomy. A little bit of developmental anatomy. We don't do a lot of that on embryology, I should say. We don't do a lot of, but you should know this is before birth, right? Usually this is the first 8 weeks is embryology, then you become a fetus. So we don't do a lot of development in this class. We'll do that in reproduction and development in AP2. Okay, and again, we're going to go to each organ system. But one word you should know, I think, in here might be coming up soon. But physiology is normal function. So you have to learn the normal function before you can learn the problems, which would be patho or disease physiology. So sometimes we learn from that, though. We learn when something goes wrong. And I like to talk about that because I teach more medical classes and we talk a lot about pathophysiology. But in order to get to that, you really have to know how it works normally. But it helps to throw that in once in a while. So sometimes we'll stop and we'll talk about certain pathophysiology, especially when we get to the first system, which would be integument and problems with bone, hormonal problems with bone, and then muscle and nervous system. Okay, so we could look at all the way down to cellular level, like in those levels of organization, the molecules and the organelles. Like some organelles you see in certain tissue, some you don't see so much, or organs even, right? So we have to go through all that. Like there's a word, again, I'm just going to stop for a minute because I know you guys are probably getting tired. You okay, Christina? So did you ever hear of the word mitosis? Mitosis, it's cellular division, like nuclear division of a cell. So a cell, and these are not your sex cells, like your 2 sex cells for male anyway. Hopefully you don't have both because that would be really hard to deal with reproduction. But the male has the sperm and made in the testes, and the female has the oocyte or egg made in the ovaries. Those are not somatic cells. Those are gametes or sex cells. They don't undergo mitosis to reproduce. They start out with mitosis, but they undergo meiosis. So if you want to get the difference, again, we're going to go over this again. But if you want to know the difference between mitosis and mitosis is somatic cells, which is anything that's not a sex cell, that's not a sperm or egg. So we're going to talk about meiosis. So I'm sorry, mitosis more. Mitosis, nuclear cell division of somatic cells. So basically what happens with mitosis is very simple. I mean, it's miraculous, but I don't know how the hell it happens. But what happens is you have one cell that duplicates into two exactly identical cells. Genetically, the number of chromosomes is the same, 46 chromosomes in each cell. So not every cell or every tissue undergoes mitosis. Like, this is a little advanced question right now if you haven't had biology in a while, but what do you think? Which tissue undergoes more mitosis? Epithelial tissue or nervous tissue?
Epithelial.
It does, by a lot, right? Nervous tissue hardly undergoes mitosis. Pretty much like the brain you get when you're born in maybe a year or two, that's the brain we have now, right? But our epithelial tissue, geez, since I've been sitting here, I probably had dust bunnies under my desk from how fast those skin cells are turning over, the epithelial tissue is turning over, right? And blood cells, connective tissue, some of it's mitotic, not all of it, but some of it is. Some of it's vascular. Vascular means it's blood supply. Avascular, like if you see the word, like a letter A in front of anything, like avascular, amenorrhea, anuclear, that means it's not there. Let me give you a little hint, like a red blood cell. Everybody knows what a red blood cell is probably. And a red blood cell does not have a nucleus. You got to remember that. So we call it anuclear. It doesn't have a nucleus. So epithelial tissue is avascular. It doesn't have a network of blood supply directly to it. It relies on intercellular fluids to transport things like sodium, potassium, glucose, insulin, calcium, whatever it needs to survive. So back to mitosis, epithelial cells undergoes a lot of mitosis. So the organelle that helps out with mitosis is called centriole. So there's a lot of centriole in your epithelial cells, but very little in your nervous cells, like your neuron. So you got to look for these organelles. You got to look for what this all means coming down to it. So just wanted to bring that up, just so you look at these different levels in the physiology, the normal physiology. So you have to know what's what after you learn all those levels of organization. Again, back to very simple stuff. Just function always mirrors, I like to say mirrors, structure. You know, why in our histology or cells of our intestines have little straws in them called microvilli, which are little proteins that help absorb your vitamins when you go to Chick-fil-A, and just in case there's some vitamin D somewhere in there, right? Or some vitamin C or amino acids that when they're broken down in your digestive system can be reabsorbed and help build more proteins. So the structure mirrors the function very, very greatly. Of course, this is an obvious thing. Teeth are sharp, so you can have that carrot, right? I don't know if they have carrots at Chick-fil-A, but you need teeth when you go there. I know that, unless you just get one of those milkshakes or lemonades. So all those parts will have a structure that's going to help with its function, and for a good level, a good reason, I should say. So here's our thing that we started out talking about, our levels of organization, chemical level, and it doesn't say subatomic, but you're going to have to learn about the electron, the guy or girl that loves to party. And you should know what a proton and a neutron is, because you might have to know what an isotope is, just in case, right? And the molecules, you've got to know the organic macromolecules. And a lot about them. You're going to have to know that glucose is a monomer of a polysaccharide. It's a monosaccharide. It sounds like a lot of crazy stuff, but you're going to know it. You're going to know how they're formed and the chemical reactions and the enzymes needed. Enzymes are proteins that catalyze reactions, like building up proteins or breaking down proteins, building up carbohydrates, breaking them down. And we need water. Remember I mentioned water, that inorganic molecule that's miraculous? Well, we need that for all our chemical reactions. And then the organelles, I threw that in there. That's cool. We talked about that. We're going to learn about my favorite, the mitochondria, and the second favorite, which is the ribosome and the endoplasmic, rough and smooth endoplasmic reticulum, Golgi apparatus, all these things. So you just keep saying it over and over and you'll remember them. Then the cellular level, we'll learn the cell, each cell. Like we're gonna look at a cell that's like the Mercedes-Benz of cells. It has all the options, but it depends on what physiology that particular tissue wants to have or have an outcome with, then it might not have all the options, right? Like respiratory cells in our upper respiratory and part of our lower respiratory system. We have to be concerned about what comes in, right? So the epithelium has structures on it that keeps moving things either out or deeper to get rid of it, like something horrible like a virus, like a COVID coronavirus, or just some dust or smoke. So you're going to hear about cilia that you might see there, but you might not see someplace else. And mucus producing cells that you have in places, because epithelial tissue does produce and secrete as well, like glandular. So you have a lot of mucus in your respiratory system. You have mucus in your reproductive and digestive system. So we'll look at single cells and we'll look at all the parts, like what could the cell have? And what organelles do they have more of? What extensions? Like a sperm cell is very easy because it just has a big tail on it. It's the only cell in our body that has that huge flagellum tail. So that's like an extension, but it has a nucleus. It has chromosomes, not like a red blood cell. Red blood cell doesn't have a nucleus, doesn't even have DNA in it, doesn't even have a mitochondria. Just anybody know what a red blood cell? Let's get this over with. I mean, we're not even learning this, but what does a red blood cell do? Like what? Why do we have red blood cells? What's its function?
It transports nutrients.
Which one? Like a gas. It transports a gas.
Oxygen.
Yeah, O2. O2. It's a life raft for oxygen. It doesn't need a nucleus for that. So this would really be a difficult question now, but it's kind of simple when you think about it. Why doesn't a red blood cell undergo mitosis? Because it doesn't have a nucleus. So it just dies, right? It's made in the bone marrow, the red bone marrow. It lives for about 4 months, cruises around your blood, dumping oxygen off, picking it up, dumping it off, carries some carbon dioxide too. It has some nutrients, but really only so it can survive that 4 months. And then it's just broken up and sold off for its parts by the liver and the spleen. So its parts are hemoglobin and iron and some proteins, some vitamins, and then they're rebuilt and turned into stem cells again in your bone marrow. So that's the normal physiology you have to learn. And red blood cells are important because oxygen and ATP is so important for life in our body, no matter what tissue or what organ system we're talking about. And then tissue level, I think you guys know this already. I think we've been talking about it long enough that you could tell me Gabriella, you could probably tell me right now what the 4 basic tissue types are. And that's epithelial, muscle, and there's 3 types of muscle, connective tissue, which is probably the most confusing, but we'll get through it. And then nervous tissue, that's it. All right, so we know the 4 macro organic, and we know what's organic now. And you should remember that carbon dioxide is not an organic molecule. Okay, then the organs, and again, we're going to have to go through these step at a time because now it's more complicated because you have all the tissue types in one place and there's different functions. So go through the organ system PowerPoint that I have. I even have a narrated one if you want to listen to it. I hope it's there. And each organ system, now this we have to take our time with because we have to go through one at a time with integument, skeletal, muscle, and nerve. But again, get acquainted with the other ones, like know what the endocrine system is, and then you can put it all together in the organismal level. So I mentioned the word endocrine. Endocrine, we're not doing endocrine system. But I like to tell you this now, at the beginning of the semester. Endocrine system is mostly about hormone release, hormones. Okay, so endo means within, and crine implies secretion. So endocrine products like hormones secrete, is very important, secrete into the blood. right into the blood. We talk a lot about blood, even though we're not doing blood this semester, the next semester. Then, you know, and hormones, and we'll talk about that in a second. Then we have exocrine. And this is like more of secreting. It's not hormones ever. It could be enzymes, but they secrete endocrine cells, which are epithelial cells basically, secrete out of the body or into tubes we call ducts. We can call them ducts, tubes. So exocrine is like salivary enzymes that are secreted into your oral cavity, and then there's enzymes secreted into your small intestine. You have sweat glands and oil glands that secrete out of the body or into cavities or ducts. Your ear glands secrete wax. It's all exocrine. But I think the best example is digestive enzymes, which again, we're not doing this semester. So we'll talk about other exocrine release. But we're going to live with the nervous system, endocrine, and the endocrine system you're not going to do. You're not going to learn all the hormones this semester, but you're going to have to know a few, right? Anybody name a hormone? Like, what estrogen? I like that. That was a great one. That was what I was thinking too. Like estrogen is a hormone. And estrogen is made and secreted from the ovaries in the female. Female has 2 ovaries, and you have to know where they are, and you have to know what body cavity they're in. They're in 2 different, I mean, they're in abdominal pelvic, but they're on both sides because there's 2 of them. So the ovaries make and secrete estrogen. Estrogen is a hormone that's a steroid. It's a lipid. Same thing with progesterone. So you have to kind of know that. Well, you will know that when we talk about chemistry, but I'm just introducing it now. So it's a steroid hormone. And all steroids are based on a molecule of cholesterol. So you have to know, like now we're going back now, oh wow, he said molecule, and it's a lipid. He told me it's a lipid. It's organic. It's big. It's a macromolecule. And you're going to learn that lipids don't like water, and they don't mix with water. Like you've mixed oil and water and then in a flask or a cruet, and you see that they really don't mix for long. So a steroid is a lipid, non-water soluble, and estrogen is an example of a steroid. Progesterone too, and testosterone, which is secreted by your male testes. So estrogen is part of the endocrine system. Now, what's the female egg called? Anybody know that? It's always 2 O's, like oocyte. Right? That's the egg. And females get about 400 to 500 viable eggs that can be fertilized in their lifetime. So estrogen is released, and that's really important for all female development, all ovulation, making follicles, making oocytes. Estrogen is the queen of all female hormones. So, but it's not released into the fallopian tube, it's released into the blood because it's endocrine. And oocyte is not going to be, it's not a hormone, so that's not going into the blood. That's going into the fallopian tube. So hopefully on a Friday night, the oocyte could hang out and meet up with a sperm. And then the sperm nucleus confused with the oocyte nucleus, and they form that first cell. And that becomes an embryo and implants in the uterine wall. But the oocyte is not going into the blood. That's more exocrine, like sperm and sperm and testosterone. Endocrine would be the testosterone, the hormone, secreted into the blood to help. And both of these, estrogen and progesterone, are very anabolic. They build proteins. They build protein. They build bones. They help build muscle, especially in the male and the female too. So testosterone is endocrine, goes into the blood. But sperm is exocrine. It's secreted into the ejaculatory duct, into the urethra. So hormone in blood, endocrine. And that's what I'm trying to tell you there. So that's going to come up a lot, even though you're not doing endocrine. So this is a picture like I think, we'll have this guy playing soccer here. And, you look at different body positions. We'll do that. But the point of view, he's the organism, I think, eventually. You start with don't forget subatomic. And then you go the root. You go to atoms. And we know the atoms, Chan, molecules. You have inorganic, like water. You have organic, like the big four, carbohydrates, protein, lipids, and your nucleic acids. Then you have your organelles. We'll learn all those. And then you have your cells, like a smooth muscle cell. You put all the muscles together. You have smooth muscle tissue, which could be the lining of your blood vessels, the lining of your digestive tubes, reproductive tubes. Like here's a blood vessel that's not, I shouldn't say lined, it makes up the wall. And you're gonna have to look at that histology of smooth muscle and tell the difference between smooth muscle, cardiac muscle, and skeletal muscle. So that's part of the cardiovascular system. You know, and this is where the blood cells go through. It's called the lumen, and has a lining that's actually epithelial tissue. This is a blood vessel. And you have to know what the aorta looks like. You know, the aorta is the largest artery in the body, and that's about as far as we go with naming arteries, but you have to know what the walls look like, the inside, the middle, and the outside in histology. And then you put the cardiovascular system together, and that includes the heart and all the other blood vessels like veins and lymph system. And then you have your cardiovascular system, and then put all the systems together and you have your organism. Okay, so this is just probably a little slideshow you can run through. And you know, it sounds repetitive, but you know what? You know this, you're on a good footing for the rest of the semester. Just when we get into the heavy physiology, it's really going to be a lot. So what are we talking about? Requirements for life. And these are more like characteristics too, but what life needs to go on and survive, right? So maintaining boundaries, of course, they're going to talk about cell membranes and linings. Movement is big. Dynamics. I like responsiveness a lot, and the nervous system has a lot to do with responsiveness. Digestion, being able to give your cells the energy they need by breaking down big macromolecules like the Chick-fil-A, breaking down proteins to amino acids, and then absorbing them in your small intestine, breaking down carbohydrates to glucose and absorbing that in your small intestine, breaking down your triglycerides to fatty acids and absorbing them in your intestines. Right? Metabolism. Now, metabolism doesn't just mean your BMI, like how many calories you need, or not BMI, sorry, BMR, where you base a metabolic rate, where how many calories you burn just by sitting around. Metabolism, and I'm going to define it right here, is the sum of all chemical reactions in your body or in your cells. What the hell is he talking about? So chemical reactions you're going to see, and I mentioned this term kind of quickly before. Did you hear me say anabolic? Can I throw that in when I talked about estrogen and testosterone? Anabolic means to build up. So what are we building? We're building up mostly proteins. When something is anabolic, like a hormone, like growth hormone, or estrogen or testosterone is anabolic, they increase protein synthesis. But then there's catabolic reactions, which breaks things down, like breaks down what you're going to hear a term called glycogen, which is our storage form of glucose, glycogen. I'll say that a lot of times later. So we'd have to break down, if we break down glycogen, that's catabolic. So there's not a lot of hormones that are catabolic. Does anybody know a catabolic hormone that's an anti-inflammatory? Sometimes you get it when you have like a swollen ankle or something, your knee is in pain. Athletes get them sometimes to decrease inflammation, but it's catabolic. Anybody know what that is? It's called cortisol. Cortisol is a catabolic hormone released from your adrenal cortex. So that's an example of a catabolic. So all the chemical reactions, anabolic and catabolic. So building up proteins, breaking them down to amino acids, building up carbohydrates, breaking them down to glucose, building up triglycerides, breaking them down to fatty acids. So the sum of all that energy to do all those reactions is your metabolism, I should say your metabolism is metabolism. So when I say we need ATP for cellular metabolism, that's what I'm talking about. Getting those reactions to go. excretion, elimination of wastes. So we're not going to talk about digestive or urinary in this semester, but we have to get rid of carbon dioxide. I don't care what system we're talking about. We don't want too much acid in our blood, right? Acid is bad in high amounts. We'll talk about that in chemistry. It's a little complicated. So that H ion, that hydrogen ion, is what in excess. You've heard of pH. pH is percent of hydrogen. So the more hydrogen, the more acidic. So we'll talk about pH later because it's an inverse scale and it's kind of difficult to understand. But let me ask you this. Now, let me just tell you two more things before I ask you this, and I'll take a break. Reproduction is important. Again, reproduction, I know the Friday night story with the sperm and the egg and all that, how that goes down. But really, reproduction, the most important thing about reproduction is getting my DNA, or getting the DNA from past generation to the next generation, and survival of the organism, right? Making sure we get strong, nice, diverse DNA, genes, and protein synthesis through reproduction to allow the human to go on. So the last one is growth and repair, right? I should put repair here too. You break a bone or you injure yourself. Its ability to repair. And sometimes that's through growth. So these are really important things. I'll probably never ask you like to name all these and write all these out, but we're going to talk about each one of these in one way or another throughout the body systems. So before we take a break, I want to ask you, what's the word that means balance in your body, or keeping a constant environment, consistent environment, equilibrium?
Homeostasis.
Yeah, man, you got it. Homeostasis. And that's the goal for all these mechanisms. That's the goal for metabolism, to maintain homeostasis. And that's how we stay healthy. That's how we keep the metabolism going. So if we go out of homeostasis, then we're going to be sick. Okay? So we'll talk about that when we get back. Everybody doing okay? We're here late tonight. You guys all okay? Freaking out? Overwhelmed? Where's my teddy bear? Where are we at? So, what time is it? What time are we here? It's 1:50? Okay. So, let's take a little break. Take a break till it's 8:05, around there. Let's take a break till 8:30, okay? Everybody okay with that? I mean, I didn't want to go into chemistry anyway in this lecture, so I'll slow down a little bit and we'll take it easy. We'll go through it a little bit slower because I want to finish with feedback mechanisms, and that's a little bit more complicated. All right. So, and